Hey physics fans, just continuing here with the coefficient of friction and friction topic here on Physics 11. We finished off there was an example that we just finished up here with the plow and got the coefficient of friction that way. Then I just want to now talk more about the coefficient of friction and the two different types of friction. Read the coefficient of friction here is that values of mu have experimentally determined. Okay, we can't just scientifically look at it and go, that's it. We have to actually measure them. And they're tabulated and put in the handbooks and stuff like that. And the more the surface molecules tend to adhere to each other, the greater the coefficient value of coefficient of friction is. And the greater the frictional force. So there's two different types of friction. There's sliding friction and static friction. And they look very similar, except for there's mu s here and a mu k there. And there's just an equal sign here, and then it's equal or less than here. Let's just do a demonstration here. A little bit overwhelming here. Let's take a look. We have a man that's going to try pushing, and he pushes 50 newtons onto this set of two crates and a little girl sitting on the top. And he pushes with 50 newtons. And the force of friction is 50 newtons. They're equal. And they're not moving. Okay, let's just decrease this to 45 for a reason. You'll find out in a second. I'm going to 95 pushes back with 95. 145 pushes back with 145. 195 friction pushes back. So it's matching. Every time the guy pushes harder, the friction pushes back. And even harder, 295, and it doesn't move. And because it's not moving, the forces have to balance, therefore the friction is increasing. And 245, so what's happening here is that this frictional force is increasing. We're not moving. So the static friction could be 0 as it started off with, and as we pushed harder, this increased. The static friction is, so it's less than or equal to a certain amount. And that certain amount in this example is 345. Okay? If I add one more to it, it's going to start sliding because that's the maximum it can go. If I push with 346, this can't. So it starts to slide. So watch it as I do it. Boom. And I'll hit play now because it's not equal. And it stopped. It didn't stop, sorry. It dropped. This friction is now less because we're moving now. Beforehand it was 0, and there's a net force now. As I pull away, as I pushed with one more, this couldn't push back anymore. So that means it started to move. And the moment it moved, this dropped. Why? Because kinetic is once it moves, it changes to a different one. And mu k is less than, as if you read down here, it is interesting that the values of static friction coefficients are always greater than the sliding of kinetic. Okay, and if we take a look here, take a look. There's the static, and then there's the kinetic. So as it starts sliding, from stationary to sliding, you start slipping, and it goes down. The friction drops. The friction drops. The coefficient of friction drops, so the amount of friction drops. So that's what happened here. So it dropped. So if I just kept on pushing with 346, it's going to accelerate because that's the net force. Now if I push backwards or let it go down, the net force is less. It's going to slow down and come to a stop. The moment it comes down to a stop, boom, this goes to 146 because it balances, because it's at rest. Now I increase my force back up to 346. It starts moving because I broke it. Let's just go by one less, and then, okay, it stopped. Boom. I'm pushing with 45. Push with 145, 195, 245, 295. It's static, it balances. Then I can push harder and harder and harder, and this frictional force, which is less than the 345, then is a kinetic friction, and therefore I get a net force, and if there's a net force, then there's an acceleration. See, I'm going faster and faster and faster. Once I reach this speed here, my guy stops pushing. Bam. Happy. Now there's only no more push force. So there's now only a frictional force. And that is slowing it down. And once it reaches zero, what happens? What's this frictional force going to be? This is kinetic friction. It's not going to be kinetic because it stopped. It's going to be static friction. And which is zero because I'm not pushing it. So it's not. So there is your quick demonstration of what this page was trying to say. So read through this page, try these examples, and then try some of the quizzes. Thank you very much. Enjoy.